Here's your Unit 1 Exponent Study Guide explained. For Part 1, you are to expand and evaluate each expression. 4.5 to the third power means there's a base of 4.5 three times. So it's 4.5 times 4.5 times 4.5. Then evaluate means to solve. So 4.5 times 4.5 times 4.5. And that equals 91.125. Or if you wanted to round it, I suppose that would be okay too. If we round to the hundreds place, it would be 91.13. Number 2, same directions, expand and evaluate. For this one, there is a negative, so we'd want to make sure we include the negative as we expand it each time, because it's in parentheses. So 1/2 to the third power. Now to evaluate it, you would just multiply the numerator, 1 times 1 times 1, which is 1, and then the denominator, 2 times 2 times 2, which is 8. A negative times a negative is a positive, but times another negative creates a negative for your final answer. So negative 1/8. The next part, simplify and leave your answer in exponential form. Then explain or show the property that was used. So we're going to simplify and leave our answer in exponential form. We're not evaluating. So 6 to the third times 6 to the fifth is 6 to the eighth. We know this because of the product of powers. So that would be the explanation. So to show this, it would be 6 to the third, which means 6 times 6 times 6 times 6 to the fifth. So there's 3 here and 5 here, so altogether we get 6 to the 8th power. For number 4, it's a division problem. So for a division problem, we keep the base and subtract the exponents. That's called the quotient of powers. To show this and explain it, I would expand and then show that 2 divided by 2 and 2 divided by 2, those equal 1. So we're left with 2 to the 4th power. So that's the quotient of powers. The next example is the power of a power, or the power rule. For this example, you keep the base and you multiply the exponents. Power of a power. To show how this one works, in parentheses, if I expand it, it's 8 to the second power, which is 8 times 8. That's what's going on in the parentheses. The 3 means there's 3 groups of this. So when we count them up, there's 2, 4, 6, 8 to the 6th power. Number 6 is also showing the power rule. Keep the base and multiply the exponents. So it's the power rule, or power of a power. To show or explain how this one works, in parentheses, there's a base of 1/3 3 times, and there are 3 groups of this. So in all, you have 1/3 represented 9 times, so 1/3 to the 9th power. Number 7 is showing a negative exponent. We make negative exponents into positive fractions. The negative exponent rule shows that the base of 7 would turn into 1/7, and there would be 3 of these, which equals 1 over 7 to the 3rd power. It would also be acceptable to evaluate that, which would be 1 over 343. For number 8, anything to the 0 power equals 1. It's the 0 power rule. And the explanation could be anything to the 0 power equals 1. For number 9, we are to place an exponent in each box so that each equation is true. I notice that this is a multiplication problem, so this is the product of power. The product of a power rule says to keep the base and add the exponents. So if we add these together, they should equal 10. So our answer could be a variety of things, as long as what we add together equals 10. We could do 2 plus 8, 5 plus 5, 4 plus 6, 3 plus 7, 1 plus 9. Any of the above answers would be acceptable as long as they add together and equal 10. Number 10 is representing the quotient of powers. The exponent rule says when dividing and the bases are the same, we keep the base and subtract the exponents. So we subtract these and try to get an answer of 2. So anything that we would subtract to get 2, like 5 minus 3, 4 minus 2, 6 minus 4, 7 minus 5. So there are a variety of answers for this one as well, as long as when you subtract them, your answer is 2.